Are we live? Are we live? So we're live. Okay, I can see in the chat that we're live, but not on Twitch. A reactive app, am I right? Right. So that's why you have to write in React, so your application is reactive enough. Hello everyone, and welcome to yet another recreation programming session with Mr. Zozin. Let's make a little bit of an announcement and officially start the stream. So we're gonna do red circle live on Twitch. And what are we doing on Twitch.television website today? Today we are rewriting my Go app in Rust. I'm gonna give the link to where we're doing all of that, twitch.tv/studying, and I'm gonna ping everyone who's interested in being pinged. And there we go, the stream has officially started. So, yeah, essentially, I just remembered, somebody reminded me, when I uploaded the VOD of the previous stream to YouTube, somebody in the comment section reminded me that aren't I supposed to like not start any new Go projects because of the whole telemetry stuff like that? And I just realized that I completely forgot about that. I completely forgot about the telemetry thing. And I suppose that was the plan of Google. That was the fucking plan of Google. So to basically make it opt-in, make people get comfortable, completely forget about it, and one day, one night, turn on the telemetry on for everyone. So I can see that. I can see their plans. So because of that, we're rewriting the entire thing in Rust, right? So I mean, to be fair, I don't really care that much, right? I don't really care that much. So if it wasn't super easy to do that, I wouldn't even probably try to do that. But I looked into what kind of things are available in a Rust standard library, the crates that come with, you know, out of the box without installing anything. And I noticed very cool things actually. So let's actually do rust app doc and see what kind of primitives are available to us. So yeah, let's wait a little bit. I think you have to do that without the ampersand. So rust app doesn't really work well with Emacs for some reason sometimes. So it's a bit weird. In fact. So essentially, one of the things we need, we need TCP connection, like very easy one. Out of the box, we have things like TcpListener, right? So you can literally just create a TCP listener, just like you would in Go, and it's super easy to accept the incoming connections. Like this is literally the loop to accept incoming connections. And so instead of Go routines, we could just use regular threads, right? So we could use thread spawn, right? So you can literally just take a function and spawn it as a separate thread. And this is something that we do in Go as well. And another thing that we rely on in the Go application is channels. And apparently, Rust does in fact have something similar to channels, right? So there is a whole package called MPSC channel. MPSC stands for Multi-Producer Single Consumer FIFO-Q Communication Primitives. And this is exactly the pattern that we use in our application as of right now. It may change in the future, but that's the pattern that we use right now. So what that means is that using only the standard library of Rust, we can translate Go application into Rust almost one-to-one, because like Rust for that specific case has pretty much the same primitives that we already use in Go. And I got really curious, like what's gonna happen? Can we easily do that? Can we just like translate it one-to-one and see like the difference and stuff like that? That's kind of interesting. Right, and again, it's kind of annoying, all of the Google drama and them pushing to collect more and more data about the users is in fact annoying, and I kind of want to push against that. But if it wasn't this kind of situation where like Rust already has all like the same primitives and we can just like translate one-to-one, I wouldn't probably bother, right? But since we have this kind of situations, I thought that's a pretty interesting topic to explore. Don't you think? Right, so just take this application that we developed. And it's a pretty small application, right? It's 158 lines of code. 158 lines of code. And just try to translate it to Rust, preserving the same architecture. Preserving the same architecture. I think it's kind of interesting. I don't know where it's gonna go, but yeah, something to explore. Remember to use Rust apt update exactly. So let me actually quickly do that. I think I didn't do that for quite some time. So why is telemetry that big of a deal? Is there no option to opt out? We already discussed that on Discord a little bit. The telemetry itself, that specific executive decision that Google made is irrelevant to the whole situation. It is irrelevant. What's relevant is the bigger picture, is basically the direction in which Google keep pushing the goalposts. You know what I'm talking about? So they're pushing like slowly to that direction. They're preparing. They tried the waters. They tried to enable it, and there was a huge backlash. They still added the telemetry, but they made it opt-in. They're gonna wait a little bit until everything settles out, and they will try again. If there will be another backlash, okay, they'll wait a couple of years. They will try again until people will accept it, and then they will say, okay, we're only collecting like how many times you build. Okay, they will wait a couple of years and then say, oh, we're also going to collect what kind of dependency do you use? It is also important for us, right? Okay, everyone's going to accept that. Okay, so another goalpost is actually knocked off. And then they're going to say, oh, we also want to know your like email associated with your GitHub. You don't mind that, right? So we can associate you. Okay, so we're going to collect that. And another goalpost, and another goalpost, and another goalpost. And on each goalpost, everyone is going to be saying that. Everyone is going to be saying that. Why is that a big of a deal? It's just an email, right? So why is that big of a deal? It's just the dependencies. It's fine. It's fine. It's fine. It's fine. And it's just like all these tentacles like slowly getting into that. That specific technical decision, it's irrelevant. It is irrelevant. What's relevant is the bigger picture. You know what I'm talking about? And of course, I don't mind them collecting the amount of builds I do. Of course, and that's the point. You're not supposed to mind that. That's the goal. That's how it fucking works. Right. I really like this one. Just a second. I just hope they don't reach the collecting how many times our builds fail. That's the worst one. That's the worst. They should know. That's the huge humiliation for everyone. All right, so we have updated. And let's just go ahead and create a hello world. How about that? So hello world, and I'm gonna do Rust C. So I'm not going to be using Cargo, right? Because I don't really plan to use any third-party dependencies, right? So I didn't plan to use any third-party dependencies. So let's actually do main, and I go. We have, in fact, hello world. I actually kind of lost it. There we go. So look at that beautiful, beautiful hello world. And it's actually smaller than in Go. Rust is more concise than Go, because in Go, what would you have to do? You would have to do package main, use fmt, and some other bullshit. So here is just main println hello world. It's that fucking easy. It's that fucking anyways, so let's actually take a look at TcpListener. So TcpListener should be pretty easy to pull off. I'm gonna do std use std-net TcpListener. So, and yeah, so it's capitalized like that. I can do TcpListener, and I can just bind to 127.0.0.1.69.69, right? So this is what we're binding to. If we take a look at the definition of the bind, it returns result TcpListener, right? So this entire thing may fail. The way I like to handle errors in Go, right? The way I like to handle errors in Go is actually map error and log them right? Just log them. But then since I'm mapping the error to unit, right? So is this value in Go called unit? Or is it called something else? Because in functional programming languages, this kind of thing is called unit. Maybe Rust is actually calling it something else. I don't really know. Does anybody know? Do we have any professional Rust developers in the stream? It is also called unit in Rust, right? So it's also called unit in Rust. Okay, very well then. It makes sense, right? So it's coming from functional languages, right? So now let's actually go ahead and say something like error could not bind, and let's say address, right? And here's the cool thing: we can factor out this entire thing like that, and that is going to work. So there is a little bit of a string interpolation. There is a little bit of a string interpolation in specifically this println macros, right? So we can use that a little bit. And that is basically it. So there could be a little bit of problem with the logging sensitive information, and in Rust it could be a bit of a pain in the ass, but that's totally fine. Right, so this entire thing now returns not just result, some sort of error TcpListener, right? So we sort of consume the error and we log the error. Now it returns this, right? And the reason why I like to do it like that is because you don't have to think about adapting the errors between like function calls and stuff like that, and using boxes and interfaces and stuff like that. And quite often, in the majority of the situation, you want to just log the error in the place that it happened. And the only thing you want to propagate upwards, right, upward the call stack, is the fact of an error happening, right? So usually error happens deep down in a call stack, and you usually know what to do with that error there, but up there, you don't really care that much about the details of the error down there, except that the error has happened. So you just use the fact that the error has happened to retry something or try something else. You usually don't care about the specifics there. So, and if you start caring about the specifics, it's usually don't have to be propagated too much upwards, just like a little bit, and it's super easy to add. In the majority of situations, when the error has happened, you just want to log it and just propagate an error, the fact of an error up and continue. And it kind of makes everything easier. Does anybody know what I'm talking about? Right, so usually you want to propagate as much of the information about error upwards as possible if you are writing a library and you don't really know all of the possible use cases of that library. In that case, you kind of propagate as much of the information as possible and expose that information to the interface. But if you're not developing a generic library, you usually kind of know what kind of information you need where and handle where, so it's not really that important, right? So the complication of handling errors comes from the uncertainty, right? When you're writing something very specific, there is very little uncertainty, so you can just hardcode things. Hopefully that makes sense. At least this is my experience. This is what I experienced over the years. Maybe it's not applicable to everybody, but I mean, this is quite often what happens, at least to me. Anyways, so, and now is just a result, and interestingly now I can just always return a result nothing, and that's basically it. And I can just like do dollar, or not dollar, question mark, Jesus Christ, and that's basically it, right? So this is a listener, and we got the listener. So we just got the listener. If we couldn't do that, we just print it and we just go up. And it feels like a C code, and it even feels like a Go code, isn't it? Right? So because in the Go code, what we did, we just opened the listener, it failed, we checked that it failed, and we logged that. And it's basically like that, except we managed to merge these two lines, these two statements, right? So in Rust, we literally managed to merge these two statements because now we have assignment and simultaneously handling or logging that thing. Right. So You can ignore the error in Go though. You can ignore it in Rust as well. There you go. You just ignored it. Or like you can do something like that and you continue the execution. You don't want to ignore it, you just do that. It's just like one symbol, you decide you want to ignore it or you don't want to ignore it. So, isn't that cool? Right? So, listener. Anyways, so it's a little bit more like a verbose syntax, right? Additional things. You need to understand how the question mark works, right? So question mark is not particularly intuitive. So there's like the syntax in Rust is a little bit more noisy, right? So it's a little bit more overloaded. In Go, it's pretty straightforward. Like there's not that much things going on, right? It's more a simplistic language. Okay, so we can try to build this entire thing and go to the compilation errors. I'm pretty sure there are some compilation errors. Yeah, because we need to probably do something like result. Maybe I'm gonna even just like do it like that, and I'm gonna have my custom result, right, which is just result that doesn't have any error but has the type T, so that makes it a little bit easier to work with. So, and in here, of course, you need to return nothing. There we go. So, and that compiled, right? It complains that listener is not used, but that's totally fine. That is totally fine. There we go. So now, what do we want to do? We want to start accepting the incoming connection. So incoming returns you an iterator. So it's some sort of a structure, and it implements an iterator. And what's the item of an iterator? The item of an iterator is a result TCP stream error. Right, okay, so we have a sequences of results. You have a sequences of results. You either have the TCP stream or an error. Right, so the error actually, oh, okay, so the error is the second one. Yeah, that's what I want actually in this case. Anyway, so we're gonna do listener incoming, right? And here we get the stream. And the stream can be like either failed or not failed, right? So we can do match stream, so you either get another stream, and in that case you want to handle that thing, and in case of an error you probably want to just log it, but you probably don't want to, you know, exit, right? You want to continue just accepting things, probably. I don't really know. We can do println error could not accept connection, and we can just supply an error in here. And just continue handling them. I'm not sure if that's good of an idea, but we're going to try that nonetheless. Okay, and that should be fine. That should compile as well, and that in fact compiles. So, and in here, what we can do, we can just print something into the stream. So essentially, if I understand correctly, it's a TCP stream. All right, it is in fact a TCP stream. And within the TCP stream, do we have something like write? Does it implement a write? Oh, okay. It implements a write interface. So that means I can literally do write ln stream, let's say, hello, meine Freunde. Okay, crowd. So, and I suppose since the stream lives for the entirety of this scope, on the next iteration is going to be automatically closed. To be fair, this thing is so simple, we can probably do it like that. Right, so we can just do it like that, and there we go. And this entire thing can return an error. So in that case, maybe we can just ignore it. Okay, let's try to compile it and see what's going to say. So cannot write into TCP stream. Because it doesn't know that it implements a write interface. We have to explicitly import this entire thing, otherwise it doesn't know how to handle that. Okay, so write ln returns results, so it wants to handle that thing. Does it have any suggestions on how to handle that better? So result error found that. So maybe we could still wrap those things in that and put semicolons in there, so the results in both of these cases are units. Can we do something like that? Okay, cannot borrow the stream as mutable, right? So you have to explicitly say that this thing is going to be mutable. So that's fine. So in result is unused, and in this case what we can do, I don't know, we can just probably log and ignore that, right? So say something like eprintln error could not write message to user. So this is going to be an error, and just ignore this entire thing, like so. There we go. Seems to be working. So that's the whole thing, right? That's the whole thing. So synchronous networking. Ew, exactly, fucking exactly, mate. Fucking exactly. So what do we want to do? We want to try to run this entire thing before we run it. So maybe it makes sense to actually say something like info listening to address, like so, right? So I'm going to rerun it one more time. And now I'm going to literally maybe go in there, right? So we'll just go quickly in there. Right, and run this entire thing. Okay, so now I can do telnet 27.0.0.1.69.69, and all right, so this is not how you do that. Okay, so hello my new friend, kick route. So it is as easy in Rust as it is in Go, believe it or not, like at least that specific part. So okay. First try, motherflippers, first try. So when it comes to sort of like a safe mode, right? So when it comes to the safe mode, how can we implement that? So because it's kind of difficult, like in Go, we could just have a single function called sensitive, right? So sensitive, which accepts a string and returns a string. And this is because Go is sort of like this very much dynamic GC-ish language. It's so easy to just allocate a string and then just like pass it around. It's just like very much, it feels like a scripting language sometimes. But so in this case, we don't really operate on the level of strings. We usually operate on the level of types that implement interface display. They implement interface display, right? So, and essentially to do the same solution, we will need to convert the displayable things into a string and only then do the dispatching whether we are in safe or unsafe mode, and it's just like kind of a pain in the ass. So the more like a Rustish solution, the more idiomatic solution, how people like to say, right? So the more Rustish solution would be to probably have a special structure, right? So let's actually create something like sensitive, and it's going to be like a wrapper around some sort of a type, right? So because of that, we're going to supply that type as a parameter, right? So, and here we're going to have like an inner type called T, and this entire thing is going to own that thing, right? It is going to own that thing. So, and then we're just implementing display for sensitive T. And we also have to put T in here. And we also have to say that T itself has to be displayable. I don't remember where we have to say that. I think we have to say it in here somewhere. Yeah, there we go. Right, so essentially for sensitive to implement the display interface, the inner type also has to be displayable. The inner type also has to be displayable. And we can have some sort of like global constant, like a safe mode, boolean true. Right, and when we are implementing fn-fmt, I'm intentionally not filling up, not writing code correctly because the compiler is going to tell me like a little bit later. But anyway, so and in here, what we can easily do, if we are in a safe mode, just do write ln for, and it usually accepts some sort of a fmt in here, but it doesn't matter. Reducted. Otherwise write ln that inner thing, right? Inner thing, and I suppose here you take the inner thing from this self, something like that. So, and the way you use that sensitive, you essentially wrap it, all right? So you essentially wrap it, you do sensitive error. I guess that's how I see that. That's how I see that. So that way, you can quite easily control what mode you're in, whether it's like true or false. But this is quite easy because it's a global compile time constant or something like that, making it more dynamic, more runtime-ish, probably going to become a little bit more difficult. But we'll see. We can probably put it behind some sort of like a reference count or something like that. There is some mechanism to have global variables in Rust. There are some mechanisms to do that. Right, so maybe atomic bool, some people suggesting atomic bool doesn't really matter that much. Anyways, so let's actually go to the compilation errors and see what the fuck do we have. Right, so what does it say? Must be string literal. So the thing I want to do, I want to compile it, tell me like what's the signature of the FMT, right? Because I don't remember it. Yeah, so we need to import std fmt, and the way I like to do that is essentially fmt, there we go. So tell me what we're supposed to do in here. So here is the methods. That's the method that we're supposed to have. That's the method we're supposed to have. So it's supposed to be like a formatter. It probably comes from here as well. Right, so we can also probably say something like this. There's a lot of stuff the compiler says to us we don't really need, so fuck that. And in here we can just do it like that. So, and this is the formatter, so we should be able to just do it like that. There we go. So that's the proper implementation. That's basically why I didn't like write it right away, because I don't remember this off the top of my head. Right, so like I let the compiler to tell me like what kind of things, what kind of weird noisy things I have to put in here, because I don't freaking know. All right, so result, remove these generics, so it doesn't need this kind of generics, right? Is that what you're telling me? Remove this semicolon. Okay, are you happy now? Okay, so has no field error. Okay, so that essentially means we could probably do something like new in here, right? So then implement sensitive t fn new, right, which accepts the t, right, the inner thing t, and returns self, and it is as easy as inner self. Inner self. Are you happy now? It is, seems to be happy. Right, and when we are in a safe mode, we should be able to just do something like that, and it failed. It couldn't bind that specific thing because it's already bound. Right, but in any case, there we go. So listening to that, but this is because we only made sensitive the error, right? So what if we made the address also sensitive? Sensitive new address. So, and since this entire thing is generic, it's supposed to work with any type that is sort of displayable, right? So, and it didn't work for some reason, like what the fuck? So if we are in a because did I fuck something up? Chat, how is that even possible? How is that even possible? Because I recompiled it, listening, and it's supposed to not do that. Supposed to not do that. So that's kind of weird. Because okay, so here is okay, so I'm actually doing the wrong thing. This is the error reporting, right? So this is the error reporting, and then I can do sensitive new address. There you go, there we go. As you can see now, it is redacted, and if I do something like that, it is not redacted. I don't particularly like this solution, honestly. I do not particularly like this solution. I think in Go it's a little bit easier to pull things like that off. I think it's a little bit easier, but it is what it is, right? So to make it more runtime-ish, as I already say, we have to use some weird forbidden magic, or maybe supply this kind of information with the sensitive, right? So basically save boolean, and then you supply it in here, and then you have some sort of, yeah, you have to propagate it a lot in a lot of things, and it's not particularly convenient. So Rust intentionally makes this kind of stuff inconvenient for you for the sake of safety. For the sake of safety, it makes it very much inconvenient for you. Right. So because we probably going to have like a global configuration, right? And for example, in Go, you already have this sort of like a global configuration. And having a global configuration in Rust is usually a pain in the ass, right? So you either have to constantly forward it to each call, or maybe have a global variable or something like that, or whatever. So, but anyway. So Yesu. So we have a sensitive thing now. We have a sensitive thing. So I suppose maybe here I'm gonna just like keep errors as usual. I don't think they're too sensitive. Maybe. So maybe address is fine, but specifically in case of an error, maybe error is in fact sensitive. So in here, can I actually just do it like that? Because I remember that in Go, yeah, we just did it like that, and it automatically listened to all of the possible addresses. Maybe that's what we can do. Failed to look up information, name or host unknown. Right, so you cannot do it like that in Go. You probably have to do it like that, and only then it will work. Okay, so if you want to listen to all of the addresses in Rust, you have to use 0000, 0000. So that makes sense. All right. So people suggesting to use TcpListener for the sensitive. It's not a bad idea. Let's actually quickly do that. I think it will make it easier, right? Because you don't like a little bit less syntax, right? And we probably won't need this kind of thing, right? So let's actually try to do it like that. So semicolon. So, and because of that, we probably want to do something like, can I do self inner, self like this, and then I can just remove that. And so when it comes to here, it becomes easier, that's for sure. It actually becomes way easier. Okay, so that's a good idea. Thank you so much. Thank you so much who suggested to use it like that. And now it is basically equivalent to what we had in Go, isn't it? It's basically equivalent, because in Go we just had sensitive, which is just a single function, and you write just a parameter to this. Yeah, it's basically equivalent, syntactically equivalent to Go. Not semantically, but syntactically. Right, so that's pretty cool, I think, right? So because there's no actual like conversion between type and string and stuff like that, we're just directly forwarding this thing to the formatter and stuff like that. So people also suggesting to maybe use something like FMT, right, as well. Also not a bad idea. So it's a little bit better even. Isu. Okay, so let's continue. So we sort of resolved the sensitive situation, right? So now we have everything we need. The struct is not required, could just make function too. Honestly, no, you can't. I don't see how you can do that, honestly. Because with at least without converting the type into string. At least without the converted type into string, I don't see how you can do that. So, and I feel like this is one of these things that people can caught up too much, because it's such a simple problem. So there's a lot of opinions, and it's easy to have an opinion on how to do this kind of thing. So I think I'm gonna claim this to be the final solution of this specific thing, and we're gonna move on, and we're not gonna discuss that anymore, because you can basically rat hole on that thing for too long, right, without solving anything. So I'm not discussing that anymore. This is how it's gonna be implemented. All right, so what else do we have? Because it's too easy to have an opinion on, very easy. So now the next thing we need to do, we need to maybe start having like separate clients that listens to things, right? So maybe even in separate threads, So let's actually have a client. And what that client is going to accept, I suppose we can just literally move a TCP stream into that thing. Right, so we're not gonna handle it, right? So it's just gonna be like this. And essentially, we want to probably spawn a thread. I don't remember in Go routines, are they real threads or are they so-called green threads? They're green threads. Okay, so it's not going to be then equivalent to Go, right? So they are in fact green threads. All right. So, but I mean, I'm still gonna be using real threads just to like map the code one-to-one. Right. So thread spawn. Right. So let's do thread spawn, so let's see how it is implemented. So it accepts a function and stuff like that. Returns the join handle, though. Returns join handle. We probably not gonna join, right? So we're gonna just continue and move on with these things. Thread spawn, and this is gonna be a function. And within that function, we can just do client string, right? So that looks fine. Might as well actually move hello meine Freunde to here, because why not? So, and this entire thing might as well also return this thing. Well, I mean, this one is gonna take care of this kind of thing. Okay, so can I even do something like this? Maybe even something like this? Well, yeah, probably have to put some equivalent here for it to actually work properly. Okay, so let me try to compile and see how well it's going to work or not. So we don't have a TCP stream. Let's include it. TCP stream is going to go here. There we go. What else do we have in here? So this is a stream. It wants to be mutable. Sure. Now, what do we have in here? This thing doesn't have to be mutable, but since we're moving it inside, it's going to become mutable anyway. Right, because the client now is the owner, which is not particularly great idea, I think. Which is not particularly great idea because it's probably going to be shared between the server thread as well, right? It's probably going to be shared between the server thread as well, but who cares? Who cares? All right, so let's create a server thread, right? So this is the server thread. And now let's just return result, this kind of thing. And what do we accept in a server thread? We, like at least in Go, server, so we accept the basically channel of messages. All right, so the channels in Rust are a little bit different actually. So when you create the channel, it creates actually two ends, the sender and the receiver, which is actually a little bit better. I like it better than in Go, because sometimes it's kind of difficult to keep track of who's the receiver and who's the sender. But maybe in Go it doesn't really matter. Maybe they're like you know, can work in both directions. But in our case, we use them as unidirectional things, and it's just like easier to track this kind of stuff, in my opinion, right? So I think it is. So let's go ahead and create a new channel. So to create a new channel, because what we're going to be storing in the channel, we're going to be storing the messages, right? So let's create maybe in num is going to be message. And what kind of messages we're going to be using in here? So client connected, so that's the first message. Then client disconnected, and then a new message. So they're also supposed to have types attached, some data attached to them. But we're not going to attach anything yet. We're going to attach it later. So, and a server is basically becomes a receiver, right? So we accept messages that are receiver of messages. There you go, something like that. So I'm going to put it like this. So this is going to be to do. So this is a receiver. So we'll need to have all of these types. So let's quickly do use, and let's include things like sender, receiver, and so on and so forth. Let's go through completion errors just to see what's going on. So this is expected found channel. Really? It's because it's like this. So channel is a function, not a package. Okay. All right, so it compiled surprisingly. All right. So now, so here's the listener and stuff like that. We want to create a channel, right? And the channel is going to consist of the message. So the first one is the sender, message sender, message receiver, like this. So, and it does that without errors. So it creates that without any errors. That's pretty cool. So then we want to spawn the server thread. Like so. Thread spawn server message receiver specifically. Right, so this is the huge difference between like Rust and Go specifically, because in Go you just create one channel and you use one handler for both receiving and sending in both of the threads. Right here, you have to put different handler to different places, right? Different handler to different places. So, and what if you're gonna have like several senders? Can you share the sender? That's a very interesting question, because we're effectively going to be sharing the sender between several places. How do we effectively share the sender? So that's a very interesting question. So maybe we should read that. So this creates new asynchronous channel, returning the sender receiver halves. All data sent to sender will become available to receiver in the same order as it was sent. No send will block the calling thread. This channel infinite buffer. This channel has infinite buffer, unlike sync channel, which will block after the buffer limit is blah blah blah, whatever. So the sender can be cloned to send to the same channel multiple times, but only one receiver is supported. This is perfect. Okay, so essentially every time we create a new client thread, we can just clone a sender and hand that sender to it. Okay, that's pretty cool. That works for me. So again, it's not going to be equivalent to Go, right? Because these are real threads, which could be a little bit heavy for the system, right? So for the system, like green threads are pretty cool that in that sense that they're very lightweight, so you can create like a lot of them. So I think in the case of Rust, we won't be able to create that many threads. As many as we could be able to do that in Go. But then once we have a working solution in Rust, maybe we can basically re-architecture the whole thing to support more connections and stuff like that, right? So, so that's actually pretty cool that you can clone it. So it fits perfectly to our use case. I really like that. Okay, so the client here, so this is the messages. So this is a single stream, and we're also accepting messages, but this is a sender of the messages, right? So this is the sender of the messages. And the client, whatever the client sends, will be received by the server in here, right? It will be received by the server in here. So now every time we create a new client, what we're effectively doing, right? So we're just doing message sender, and we just clone this entire thing, right? We just clone this entire thing. Hopefully that will work. I don't really know. So let's actually go through the compilation errors and see. Right, so we don't really use these messages, so this is a warning. So closure may outlive the current function, but it borrows message sender. Yikes. So here is an interesting thing. How can I, like one way I can do that, right? So I can do message sender like this, and then I move the message sender like this. Can I all right, so that works. It is so funny that this is the solution. It is so fucking funny. Right, because I suppose it moves these things inside of this function, inside of the thread. Right, and when you try to do it like that, it first moves message sender and then clones it. So you need to kind of clone it outside and only then move it. Like, I mean, it makes sense to me. It makes sense to me. It's just funny that that's how you have to do that. It's kind of sad that like you really need to understand these kind of things, right? You really need to understand these kind of things, which is not particularly newbie friendly. Oh, by the way, when I released that whole sort of like a rant about like user-friendly equals professional hostile, I've heard one interesting point is that like Rust is kind of an exception out of that, right? Rust is kind of an exception because it's newbie-friendly, right, and professional and stuff like that, and not professional hostile. Like if you think that Rust is newbie-friendly, Rust is not fucking newbie-friendly. Like factually. De facto, Rust is not newbie friendly. It is marketed as such for some fucking reason. I have no idea why it is marketed as newbie friendly, but it's fucking not. It is very much newbie hostile. Very much newbie hostile, I'm telling you. So, so quite often it is marketed as newbie friendly. It is really marketed as newbie friendly. But it's actually not. It is very much not. All right. So to be comfortable with Rust, you either have to do it for like a very long time, or you have to have background in pure C, C++. Separately. You need to have background in pure C and C++ separately, and Haskell, and all these three simultaneously. If you have these three backgrounds simultaneously, you would feel comfortable in Rust, yeah, sure. So or a camel, maybe a camel also fine, right? So you can replace Haskell with a camel, but Haskell would be a little bit better, right? So I have background in those three. I still don't like Rust. Same. I also have background in all of the three. I also don't like Rust, but I was not saying that to feel comfortable, right? So it's a little bit different, right? You can comfortably program in this language without liking it, but I mean it's a very subtle thing. Anyway. So let's continue. So this entire thing compiles. This entire thing seems to be compiling, so that's pretty good. That's pretty Gucci. That's pretty Tamaguchi. So when do we send stuff to this thing? I suppose we're sending message client connected before. Yeah, I don't really know why the fuck we do that in here. Personally, today, I would have actually moved that message sent inside of the function client. I think that would make sense to me, right? So just like move it there. So, but anyway, we can do it in here then. We can do it in here. So we can take the messages. And the question is, how do you send it? By the way, I'm using this channel API for the first time in my entire life. I literally learned that this thing exists before the stream. And I started the stream right away. So I'm literally figuring out how to use this thing right on the stream. Right, so sender, let's take a look. But we have documentation, right? So we have documentation. So I'm pretty sure it should have method send, right? So I mean, that's pretty expected. Right, and you just send the thing there. Okay, so let's actually read what the fuck this thing does. Attempts to send a value on this channel, returning it back if it could not be sent. A successful send occurs when it's determined that the other end of the channel has no hung up already. An unsuccessful send would be one where the corresponding receiver has already been deallocated. Note that the return value error means that the data will never be received, but the return value of OK does not mean that the data will be received. It's possible for the corresponding receiver to hang up immediately after the function returns. To hang is a irregular verb, right? So hang, hung. Okay, so I'm sorry, English is hard for me. I don't speak English. This method will never block the current thread. And to be fair, it doesn't really need to, right? So it doesn't really need to block anything. Okay. So let's send something like message client connected, right? So for now, we're not going to attach any information. So the message client connected. So map error So if we couldn't do this kind of thing, so that means that the receiver has been deallocated, and it makes sense to just like go out of here, right? So print ln, so let's say could not send a message to the server thread, and this is basically an error. And to be fair, I'm not quite sure, right? So I'm not quite sure what if I really like that, because I'll have to do that every time I try to send. So maybe it would be nice to have some sort of a wrapper, but I mean, who cares, whatever. How much money to get you to write this in BrainFog? I probably won't write this in BrainFog, but I actually want to do a BrainFog stream. That would have been interesting, I think. Like where I try to program some simple algorithms in BrainFog. Now, what do we need to do? We need to start like reading things from the buffer. So let's actually start in infinite loop, right? So apparently in Rust there is a special construction to create an infinite loop, which is kind of cool, not gonna lie. And so here we can take a look at TCP stream, right? So let's take a look at TCP stream. Does it have a read? So there is a read timeout. Oh yeah, by the way, right. So apparently the for@ is vulnerable to slow loris, but it's kind of interesting. It's vulnerable not to the writing slow loris, but to the reading one, right? To the reading one. So essentially, if we take a look at the Go thingy, and we take a look at the server thing. So in server, within a single thread, what we're doing, we're iterating through all of the clients, and we're synchronously writing things into each individual client. So if there is a one slow reader among the clients, it will stall the entire server. I'm surprised nobody tried that on the previous stream. You could have actually stalled the entire thing, right? So we're gonna actually translate it as it is. So the Rust version also will have that. And once we finish translating, we're gonna fix it in the Rust version, right? So that's basically the idea. So, but keep in mind, right? So prepare your slow loris attackers, right? So to stall the entire server. To stall the entire server. So we set the message connected, and now what we need to do, we can use the read timeout, or maybe not. Maybe it doesn't matter. So I want to just do a regular read. And read timeout. What does it return? Returns the read timeout. Ah, it doesn't. Okay. I just had a huge brain fart. For some reason I thought this is a method that performs the read with a certain timeout, and I'm just looking, where is the output? Where is the buffer into which it's reading? It just returns you the value set within the... Okay, maybe it's not my problem, because why didn't you call it get read timeout or something? Like, it looks like an action. It looks like a perform read with a timeout, and it's just like, look, where is the output? Jesus Christ. Anyway, so it probably reads through the read interface. Yeah, there you go. So it has a read interface and blah, blah, blah. So what kind of stuff does read interface have? Right, it has a limited thingy. It accepts the buffer that is mutable. I hope that the fact that this buffer is mutable doesn't mean that it's going to resize it. I'm having PTSD. Anyway, so I'm just joking, obviously. So, okay, good. So I suppose we could basically allocate some sort of like a vector. So if I take a look at the vec, can I allocate vector with a certain size? So I can do new, it's just like a new thing, new in, right. It's, the vector will not allocate until elements are published. Okay, so it's probably not what we want. So there's a width capacity, right? So there is width capacity. Is there something else? So it's probably not. We could probably resize this entire thing. Yeah, so that looks fine. That looks fine. So resize width. And we can use that as a buffer. We can use that as a buffer. Okay. So we can just create a buffer and go to vec new resize width. So there's just resize, but I suppose it oh, it's resized with a function, so the value is computed with a certain function. I don't think this is what we need. We just need this thing. So resize. So the size is going to be 64 and just fill it up with zeros, right? So this is going to be definitely like bytes. I'm not going to specify any of the types because I hope it's going to infer them somehow. Right, it's going to infer them somehow. So in here we have read, and I'm going to be basically reading into the buffer, right? So this thing has to be mutable, and there we go. We just read into the buffer. So in reading may also fail, of course, right? So it may fail. Map error, so this is an error. And what do we want to do in case of an error, right? So if you take a look at how it is implemented in Go, right? So how it is implemented in Go. In case of an error, we just close the connection, right? So we just simply close the connection. But suppose we don't really have to close it explicitly, we can just exit this entire function. So that's totally fine. But one of the things we may want to do, we want to tell the server that we just disconnect us somehow, just disconnect us. So, and we do that by doing message send, right? So we do messages, and we just send disconnected, right? So client disconnected, and we just exit afterwards. And since I put this thing in here, so it's totally fine. Okay, that's cool. So, and this entire thing should return n, and now we should be able to, oh, okay, so it works. So this is actually works too well, in my opinion. All right, that works too well, surprisingly. And of course, this can fail as well, so maybe we'll have to do something about that. We'll have to do something about that. All right, so people tell me that slices are usually like this. This is how I can take a slice, and now I need to try to convert a sequence of bytes into UTF-8 string. So can I do something like from UTF-8? Is there something like that? So str from UTF-8, okay, so, and it can fail, which is good, right? So if we didn't manage to convert it properly, we won't be able to do that. What's interesting is that we're going to be striking the people who didn't send UTF-8 compliant stuff. We're going to be striking it, and we can't really strike them on the client side. We have to strike it on the server side. So because of that, I think I'm not going to be converting it to UTF-8 here yet. I'm going to be not going to be converting to UTF-8 here yet. So I think I'm going to be sending it to the server messages, new message. Right, so new message. But here comes an interesting thing. Here comes an interesting thing. We'll have to copy this entire thing. We have to copy this entire thing. So, and the messages, the buffer messages that we're operating with in here are very small. So maybe copying them is not that much of expensive. Maybe it's not that much expensive, so maybe that's totally fine. So right now I'm just outlining how it's gonna go, right? Because we're gonna have a separate session where we go through compilation errors and stuff like that. Compilation errors and stuff like that. And so func client, that's basically it, isn't it? Yeah, that's actually smaller than I expected. Like, it's generally more concise. It is generally more concise. And in uMessage, right, so we won't be able to do something like this in here, right? Because this thing has to be owned, right? This thing has to be owned, but I don't really plan. Oh, I can do it something like that. Right. I can do something like that. So just like, because when you have a owned slice, it's basically a vector, right? So an owned like thing is basically a vector. Yeah, we can put it in a box, I guess. We can put it in a box, but I'm not sure, right? So we can just do it like that. We can just do it like that for now. Right. So in a Go version, we also were sending the sort of the connection itself, right? So the TCP stream, but I'm not sure if we'll be able to. We can't really copy TCP stream. One of the ways we can do that is probably share it between this the threads or something like that, right? So we'll see. We'll see. Yes. I'm actually unironically expecting we'll get to this point at some point in the stream. Classic Rust, am I right? So I mean, this is like, yeah, this is an unironic type. This is an unironic type that people use in Rust, right? So in each layer of this onion has a meaning. Each layer of this onion has a meaning. I suppose in this particular case, it doesn't make much sense, right? So it's just like a box itself is a pointer. So you putting it behind a mutex, like you could just use arc without any box. And I think you actually put arc inside of the mutex, I think. I don't quite remember. I think, so outer is mutex, inner arc, and then the value. This is usually how you share things between the threads that needs to be sort of synchronized or something like that. I don't quite remember. There's arc is outer. Oh, okay. Yeah. So you have a value behind the mutex, and then you need to share the mutex between the things, and that's why. Okay. So we can. I think it even has examples. I think it even has examples for this kind of thing. All right. So yeah, arc is outer. Okay. So that's true. Okay. Yeah, arc is for multiple ownership. Yeah, that makes sense. That makes sense. So I'm registering for 1 hour. So let's actually go to the compilation errors and maybe make a small break afterwards. Right. So what do we have in here? So message local. Okay. So this is a messages. No method to read for a TCP stream, and this is because we need to do this kind of thing. But we're already like importing write, right? So we're already importing write, so I can do read. There we go. So in here we can do to vec, to EVC. All right, what else do we have in here? So unused write, which is reading. Okay, so you don't need that anymore. So error, unused error. Yeah. So eprint ln error could not read message from client. Error like this, and then we just perform that. Like it already compiles. Why the fuck does it compile already? I'm surprised. So we have unused this thing, and I suppose do I really care if it fails or not? Like at this point we kind of already failed completely, so there's no point in even trying to handle this kind of thing. Right, we failed to read. Do we really care where this thing received that or not? So even if it doesn't receive, is there something we can do? Right, so there's nothing much we can do, so it's just like that's why I'm gonna just ignore it. And so here we do send, and this is map error. And if we couldn't send, that means there's no channel anymore, so could not send message to here. Okay, what the fuck do we have in here? Okay, so because this is a map error. All right. That's too easy. That is too easy. All right, so we went through the compilation errors. As I already said, I wanted to make a small break because I ran out of tea. So I would like to replenish my tea. And after the break, we're gonna move towards the server. So the real shit will hit the fan when we'll have to do something like this. We will need to have to do something like this. We'll need to somehow tell the server thread who we are. In Go, we used to do that by sending the pointer to the connection, right? In here, we could try to just make it arc TCP. Let's give it a try. Okay, so let's actually introduce arc and see if it's going to work that easily. So this is a std sync arc. All right, so use std sync arc. And arc, by the way, for those who doesn't know, it's essentially shared pointer. It's like shared PTR from C++, but with atomic reference counting, right? So it's atomic thread safe and stuff like that. That's basically what it is. Soding, did you decorate your house with Halloween shit? I do not celebrate Halloween. I'm sorry. And nobody among my neighbors celebrate Halloween. And I never seen a single person in here who celebrates Halloween, honestly. So it's not a thing in the place where I live, I'm sorry. Neither here in Eastern Europe. Yeah, I'm also basically living in Eastern Europe. So my Europe is so Eastern, it's Asia. That's how Eastern my Europe is. My favorite joke of all time. I know I made it already twice. It's right above Mongolia, exactly. We live near the border of Mongolia. We don't have Halloween here. We have. That's what we have instead of Halloween. No. Yeah, I wanted to try to do the arc thingy, right? So essentially, we're gonna do arc TCP stream. Okay, so and in here, right? So we're probably gonna pass this thing like that, right? So we're gonna pass this thing like that. This enum, but has okay. So I'm gonna put it in here, right? I'm not sure if I. Yeah, well, we're gonna keep it like that. Why not? So, and when I'm doing it like this, okay, so this is cool. How do I construct an arc, right? So this is a similar situation, right? But instead of cloning the stream, we're gonna be doing arc new stream, like so. Is it going to help us? Variable doesn't need to be mutable, sure enough. So can it borrow data in arc as mutable? Okay, so you can't borrow it as mutable. What do I have to do to make it mutable? Is there anything I have to do? So that means I have to put it behind the mutex, right? Do I really have to put it behind the mutex if I want to make it mutable? If I want to make it mutable, it looks like I have to put it behind the mutex. Looks like I have to put it behind the mutex. Though we can try to do something that we couldn't do like easily in Go, right? So we could have another sort of like a channel that through which we receive what we have to send. So that means we'll have to put like an, okay, so I feel like we'll have to do the mutex thing here. Okay. So that means it's not as easy as I expected. So we're gonna do that after the break then. Right, so let's first do the break, and after that we can continue. Okay, so here is the question. I just realized that I probably need to do an unsolved computer science problem. Right, how can I share TCP stream between two threads, and in one thread read, and another thread write, and both of these things asynchronously. Is this difficult computer science problem solved in Rust? Is it possible to do in Rust? Looks. Okay, people are guiding me in the right direction, I think. I'm not 100% sure, but I think they're guiding me in the right direction. So we're gonna try to do TCP stream, because the words like splits and locks kind of sound what I need, but I know the chat, they're gonna fucking debate me. They're gonna fucking debate me. So, but it kind of sounds plausible. Chat is basically GPT, chat GPT, right? So it just confabulates some, you know, plausible shit that isn't actually true, but I mean, it wastes your time anyway. So what do we have in here? So try clone, no delay, linger, blah blah blah. So SFD, so there's a from, into row, send socket, nothing particularly interesting. So there's a structures incoming. Well, I mean, it's an iterator that contains all of these things. So people were saying word split. Okay, so let's actually try to search for split. So there's IO split. So it's probably related to IO, right? So it probably is. An iterator over a content over instance read buffer split on particular. Nah, that's not what we want. That's not what we want. So locks. People were also saying locks. So I know that locks are a thing for std in, std out, and so on and so forth. But when I have like a TCP stream, I'm not really sure how easily I can do this kind of stuff. So, and as you can see, std lock is this kind of thing. So I feel like I can't easily do that. RW lock. So something like RW lock could be a thing. So this is for read writer lock. This type of lock allows a number of readers or most one writer at any point of time. The write portion of the lock typically allows modification. So allows a number of readers or at most one writer at any point of time. So read and write are implemented for pointer stream, meaning that you only need a shared reference, no need for mutex, for mutable mutex. So does that mean I can just use... But I mean, I tried to put arc in here, didn't I? So, okay, let's actually see. So somebody suggested. Let me see. So read. Oh, okay, so I lost this kind of thing. Freaking. Okay, so finally, yeah. So there is an annoying thing in Chromium when you basically follow the link with an anchor, but then you resize the browser. Even if you refresh the browser, it doesn't actually align with an anchor. And it's extremely annoying. I think it's been in Chrome for ages, since I remember. Like it's a very much Chromium bug or whatever. And it's just like you have to open it in a new tab to actually reset it or something. Same, so I'm not the only one who struggled with this kind of shit. It's just so fucking annoying. I'm pretty sure it is a bug. I'm pretty sure it is a bug. Fix it. Yeah. So, and like, it's just like, yeah, because quite often, like, I open it in a different window, so it had a different size. So I had to move it in a different monitor, I'm sorry. So it had a different size. So then I moved it to a main monitor, and obviously it resized, and now it just like doesn't recover. And I can even check, like in this here. Yeah, it's just like the position of the anchor is actually lost. X server moment, I mean, is that an X server or is that, I feel like it's a Chromium bug, not X server bug, honestly. So we just need to have a shared reference. We just need to have a shared reference. But when I try to do this thing, when I tried to do this thing, it didn't allow me to do that, right? So because arc is a form of shared reference. When I tried to put arc, we started to have a problem with the reason here. Right, we did in fact start having problems with the reason here. So deref on the arc. Okay, so that's a good thing. Okay, so I suppose we're learning something new. All right, so let me take a look. So what does deref even mean? Okay, so it's probably method of something, of some interface that arc implements. So it's a method of deref, so we have to explicitly dereference. It's just a deref, but why do you have to? Well, I mean, and it still returns you a reference. Okay. Okay, so that's interesting. So used for immutable dereferencing operations like that. In addition, so it basically for things like arc on maybe a box and everything, it will basically turn it into this, like, you know, regular reference. Huh, that's very interesting. Okay, let's try it again. Let's try again, use arc in here everywhere, right? Use arc in here everywhere. Maybe it will do something. So honestly, maybe I want to make it like immutable here. Oh, anyway, so let's just go ahead and try. Let's just go ahead and try. Can it borrow data as mutable deref? Right, and what did happen in here? So it has to be a method. Deref method not found in, so it didn't work. The following trait is not employed. Okay. I see what you've done in here. Okay. So value moved in here. So that's fine. That is fine. Right, because so we kind of moved it. So I suppose what I have to do in here, I have to clone it. One of the things you can do with arcs is you can clone them. So people say as ref works as well, but we'll see. So it's similar. So let's just make it work at least. Okay, thank you so much. Thank you so much who helped me, especially Mohad. I know that other people also helped, but Mohad actually watching my streams for quite some time, and their advices in the chat are super fucking useful, quite a lot. So I'm gonna give them a VIP. So you're VIP now. So I'm gonna promote you to VIP because I see you in the chat all the time, and you're actually contributing to the conversation a lot. So yes. Thank you so much. It's actually really cool. All right, so that's kind of cool that it works. Right, and people say you can do as a ref as well. So, and that doesn't require deref. One less line. Who would have thought? Who would have thought? Okay, so that's pretty cool. And since it's a reference, we can, hopefully it doesn't really move that much around. We can probably use it as the key in some sort of a hash table. Well, no, what we did in Go, we actually used the IP address in a hash table. So yeah, so that makes a little bit more sense. Okay, so on a disconnect, we also send the author. So we can do TCP stream like so. So this is the author, and we can just do it like that, string clone. All right, I'm really surprised all that compiles. Okay. So that means we're done with the client thread, basically done with the client thread. So let's go ahead and port the server thread, func server. So what did we have in here? So there we had a client map. So I suppose one of the things we probably want to have a structure client, and a structure client is rather interesting, right? So let's actually have struct client, and here we have a connection. We can have a similar connection, which is going to be arc in TCP stream. So I'm not going to do last message and strike count yet. So let's just port without rate limiting and banning and auto banning and stuff like that, because it's easier, right? So it's just easier to map the behavior. Okay, so, and then we have clients. So to have clients, we'll need to have the hash table, collections hash table, like so. A fan server. So let's introduce mutable clients, hash map. And the question is, what are we going to use as the key in there? So we used in Go the string that represents the remote address, basically IP plus the remote port. IP plus the remote port. So if we take a look at TCP stream, do we have a remote address in there? We have local address. Okay, that's cool, but it's a local address. It's not really that interesting for us. Does it have a remote address? It has a peer address. Okay, that is cool. So it has a peer address. So it's either IPv4 or IPv6. That is cool. So does it implement hash? Does it implement? It does implement hash. So we can put this entire thing as an index in a hash table. That's pretty cool. Sounds good to me. Sounds Gucci. Sounds Tamaguchi, you know, the usual stuff. So the only thing that bothers me a little bit, why the fuck does it return result? It returns the socket address of the remote peer of the TCP connection. So does it perform some sort of a system call every time you call this method? Does it not cache it? Or like, I don't really understand why the fuck does it need to return result, because how can it fail? Excuse me. So let me see. So it's a peer address. How many implementation is there? Okay, so the implementation internally, this entire thing is a TCP listener. Yeah, we have to go like very deep into this entire thing. We have to go very deep into this entire thing, but yeah, whatever. All right. So let me start coding, I suppose. Start coding. The first thing we want to do, we want to organize maybe a loop. We want to organize the loop, and as you can see in here, we have an infinite loop. So we need to take the messages, and we need to work with the receiver. So here's the receiver, and we receive things. Attempts to wait for a value on the receiver return an error if the corresponding channel has hung up. This function will always block the current thread if there is no data available, and it's possible for more data to be sent once at least one sender still exists. Once a message is sent to the corresponding sender, this receiver will wake up and return that message. Okay, so that's precisely what we want. So messages, receive, and we got the message. We just got the message. So I'm not really sure how should I react to a receive error. So if the message is hung up, so an error if the corresponding channel has hung up. What does it mean? Does it mean that it doesn't have... Well, it's probably gonna hang up if we lost all of the message senders, but there will be always at least one message sender from which we're cloning things. So yeah, that's actually pretty cool. So from which we're cloning. So that means even if there's no clients, it's never gonna be hung up. Right, so that means that's totally fine. So we can do something like map error. We can log the error. So it should probably never happen, right? So it should probably never happen. Because of that, we can just expect that it's going to be fine, right? So expect the channel, the server receiver is not hung up, right? So this is what we're going to do here. We just take the message, and we can have several situations in here. So we have that. So this is the author, right? So this is the author, first author, then disconnected, and then new message, right? New message. There we go. And this is basically the bytes of the message that we received. Okay, so let's go ahead and compile and go to the compilation errors. So unresolved import collections hash map. Okay. All right, message like this. I mean, technically, like, it's correct, I suppose. Unreachable expression, so... All right, let's remove that. Annotation needed for... type annotation needed for hash map. Okay, so it couldn't figure it out yet. So because of that, I need to... Well, I mean, it's not going to be needed as soon as I try to push something in there. So it's annoying, right? So I can just add it right away to make it compile, but as soon as I like implement at least this thing, it's going to be fine. All right, so it's kind of forcing me to implement it right away, which is annoying in my opinion, but whatever. So here's the author. So this is already a connection. So we have a peer address. So this is a peer address, and we probably want to pre-cache it somehow, right? So it doesn't, like, we don't call it very often, but I guess that's fine. So it's going to say expect to do cache the peer address of the connection, right? So this is something we want to have in here. So this is going to be an address like so. And then what we're doing in here, we're just adding this thing in there, right? So we're just adding a new client. So clients, insert, and we can do a client like so. This is the connection. So this is an address, which we probably have to clone, right? So I'm pretty sure it is clonable, so we're gonna clone it. And what we're doing, we're taking the author and we're cloning the author as well, right? So we're storing the copy of that arc thingy in there. And that's basically it. So that will not require to provide any parameters in here anymore, hopefully. And compile, yeah. So it kind of forces me to go implementation before I even manage to compile this entire thing, because I cannot figure out the types. It's kind of annoying. It's kind of annoying, but it's Rust. It's supposed to be annoying, right? So it's designed to annoy the fuck out of you. Right, so we have this, but it's unused, so that's fine. That is totally fine. That is totally fine. Okay. So when it comes to client disconnection, what do we do? We take the address yet again. So author. I might as well copy paste this entire thing. And what we have to do, we have to just delete it from the map, right? So we have to delete it from the map. If it doesn't exist, I don't know, we're just gonna ignore that fact. So hash map. So do you have delete or is it remove? It is remove, okay, so that's fine. And it returns an option. Yeah, we don't care if it exists or not, we just remove it, right? So clients remove address. So it has to be by a pointer, by a reference, right? So we have to do it like that. So let's recompile this one more time, and it seems to be working. Okay, so we can quite easily just add and remove from the map and stuff like that. So the next thing we have in here is send the message. So to send the message, we'll have to be iterating the hash map. So hash map, I think it has something like items, if I'm not mistaken, right? So, well, you can just do iter, and it gives you an iterator, the item of which is what? A pair of key value. We can do something like that, right? For client iter, right? For client iter, and we can probably just take values. Something like values is even better. Hash map values. Right, and it returns you an iterator of only values. That's a little bit better, so we can do values. So this is the client in clients. That's pretty cool. Though, okay, we'll need a key anyway. Right, because it's going to be an address. Right, it's going to be an address. So, and we'll have to do this thing as well, but this is going to be author address, right? So, and we need all of that because we're going to be distinguishing if address not equal author address, only then we want to send that to that client and blah, 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 right? So, okay, so maybe I'm going to actually follow the code in Go, right? So as you can see in here, we just take the client, we take the connection, and we're just writing that entire stuff in there, right? Just writing those bytes right in there. Very dangerous thing, right? So we don't screen them, we don't do anything with them, we're just writing them in there. And if it fails, right? So in here, if it fails, we also don't care if it fails or not, right? So we also kind of ignore that fact, right? So let me see, does it compile? So we need to wrap that in parentheses. Thank you, compiler, very much. Not found in the scope. Ooh, okay, so new message must contain not only the bytes, but also the author. So one cool thing that I use in Rust quite often is enumerations that also structures. So essentially I can do things like this, right? So this is the bytes and this is the author, which is also arc this thing. Right, and it makes it a little bit easier to pattern match things like that, right? Because then I can do author, bytes, and I can just like use them directly, right? Because there are corresponding fields in here. So I might as well even turn that into these things. So this is the author, like so, and this is author as well. And porting the pattern matches to like a new kind of thing is super easy. You just replace the parentheses with curly braces, and it's basically the same, right? It's basically the same. That's actually very, very useful, very cool. Can your Go do that? Go doesn't even have a pattern matching, right? Okay, let's try to compile that. Oh, it created even more errors. Okay, so iter is not a method of not found for arc client s. Client s. There we go. And here, no. Okay, so this is because it's that. So we have to do as ref. And okay, so this is cool. Who is the reference? Who is the reference? I suppose. Can I just do EQ not? Right, because expected this and this is like this. Right, so it will actually compare like values, right? It will actually compare the values, if I understand correctly, right? So let me find the method EQ. So it's actually part of the point. It's kind of dangerous. Yeah, we have to be super careful. So this is a value and this is a pointer. So to be 100% sure, let's just do it like that. Right, let's just do it like that. So we have to be super careful. But I mean, I think Rust in this particular case won't allow you to shoot your leg. So I don't think it's that big of a deal. Oh, it cannot find the method right because I removed it. It's the Rust warnings and shit. So, and here we want to do that by a reference. And here when we send in a message, right? When we send in a message, yeah, we have to do it like that. So this is the author, right? So now it is like this. And here, when we disconnect, now it is like this. Can you, by the way, see shit? Okay, it's author like this. There we go. And this one is a little bit interesting because this one is bytes that we're sending. This is the bytes that we're sending, and this is the author, which is a string clone. I wonder if constantly cloning that reference is too expensive. It probably is. It probably is. But it compiles. And you know what's funny is that we basically translated the functionality of the server without the you know, message rate limits and auto banning. So the functionality is translated one-to-one using the same architecture, the architecture of a single server thread and several client threads, and like you know, a single consumer, multiple publishers. So this entire thing is basically translated. So, and this is precisely why I decided that, like, to try it out, because again, as I already said, Rust has pretty much the same sort of like paradigm primitives. But we haven't tested it yet, of course, we haven't tested it yet, but it already compiles. And as you know, as they say in the industry, if it compiles, chat, say the line, chat, say the line, if it compiles, it works, yay! Anyway, so let's give it a try, let's see if it's true or not, I don't fucking know. Look at that. Can I now do a telnet on this thing? Hello. We can't really see anything, so let's try to maybe connect to another one. Right, so let's actually put it like this so you can see everything. So let's do telnet 27001 6969. Hello. What the fuck? Hello, how are you doing? Smiley face. I'm doing fine, thank you. So first try, by the way. So how do I quit this shit? So, and I never worked with that API before. I never worked with this API before, so, and I just like managed to learn it right on the screen and on the stream. So, and the functionality has been like literally ported, right? So one-to-one. And I just translated the code. So the only thing we're missing is the strike system, right? So, and stuff like that. How can you still dislike Rust? Because I think it's too much effort for what I wanted in here, honestly. It's very bureaucratic, especially when it comes to just sharing a reference between the threads. You may argue that it is intentional because it's a very dangerous thing and it's very easy to shoot your leg, but I don't like how Rust prioritizes safety too much over convenience and ergonomics of the language. Right, so essentially, there's two things, like ergonomics and like ease to use of the language, and the safety. Safety is important, but what Rust does is that safety completely ignoring ergonomics. It's like fuck ergonomics, right? So completely fuck it out of the window. And that's what annoys me. Like, can we optimize both? Can we optimize both safety and ergonomics and stuff like that? But if I feel like it's kind of difficult to pull off in the current Rust community, because the Rust community is just like, there's too much discussion going on in Rust community, because quite often for a simple sort of feature, there could be thousand and thousand and thousand upon thousand comments discussing rat holing over like an important thing and going nowhere, and it's kind of like, I don't know. Sometimes I feel like Rust lacks a coherent vision, if that makes any sense. You know what I'm talking about? It's just like, their vision is just safety at all cost, right? Just safety at all cost, and that's the entire vision. And it's just constant fighting and drama and stuff like that. So quite often, I know, projects that maybe Rust needs like a benevolent dictator, if you know what I'm talking about. So if you take a look at the project with benevolent dictators, they usually have like a very clear, coherent vision. Right, clear, coherent vision. Even though sometimes some people might be not happy with this kind of stuff, but at least there is a coherent vision. Python 2. I don't know. Maybe I'm saying that because I'm authoritarian. That's why. So this is my authoritarian part of me speaking right now, right? So yes, project needs to have a benevolent dictator. Yes, I know what I'm talking about. Not authoritarian whatsoever. So then why are you so authoritarian? That's a good question, actually. Sometimes I do feel that I am a little bit authoritarian. Say that in Russian. But if you don't speak Russian, you won't understand that. Or, like, do you speak Russian? I don't know. I don't speak Russian. It's very difficult English. Okay. So, let's go ahead and port the, you know, the rate limit system and the auto banning system and stuff like that. I'm losing my voice, by the way, but it is what it is, and it is what it is. Do we have time, by the way? And I'm not talking about like the real time in, right, in Rust. We do have time. There's a std time. And do we have... Okay, so there must be something like time now. There is. So there's a time instant now. So what is an instant? So let me read about an instant. A measure of monotonically okay, so it's basically a clock. Right, it's a clock for maybe performance measure or something like that. Right, so so we probably need to use a system time, right? But to be fair, if it's a temporary ban, right? If it's a temporary ban, maybe we don't need a system time. Whatever. Let's use a system time. Yep, clock. System time. There we go. So let's open the Go implementation. Struct. Where is the client? So struct client. So there's a connection. Last message, right? So we need to have last message and system time, right? So, and we're also gonna have I don't remember. Do you have to put comma in here? But the compiler will tell me. Whatever. Strike count. So this is a strike count. Cool. So yesu. So we also need to introduce a thing called band MFS, right? So that's very important. So we have band MFS, band motherfuckers, band motherfuckers. Okay. So can I split it slightly differently? Yeah. So the first thing we do in here, we take the address of the author, right? So here it is. This is an address, which is kind of cool. And we have band MFS. Band MFS. We need to check. We need to get, you know, the thing when they were banned. Banned at. Well, I mean, we have to find a method in hash map that gets a value, right? And it usually returns an option indicating that it might be missing, right? It indicates that it might be missing. So, and here we have like, this is a very convenient way of doing that. So now I have to do a completely different way of working with this kind of thing. I know that hash map had a take. I think it had a take. Hash map take. So essentially take accepts a value, right? Removes and returns the value. It's a hash set though, but I want it hash map. Hash map take. Yeah. Well, it doesn't have a take. Okay, whatever. So the problem is that it's not really easy to translate the Go code to whatever we have in here, but that's fine, I suppose. Author ADDR. And in here we're gonna have the band at, but that band at is essentially option. But maybe that's fine actually. Maybe that's actually fine. We can't translate that because we can, yeah, we can use band at as band at and band simultaneously. We can do that. We actually can do that. That's very cool because now So essentially, if let some band at, that's what we do. So we also keep track of the now, which is basically system time now, right now. And if so, there is some sort of a subtraction system time. So do you have sub? You do have sub. So basically, Rust and Go, they are stealing from each other. So who stole from whom? Who stole that idea from whom? I don't freaking know. So, and apparently you can probably use a minus operator. We could try a minus operator, why not? So, and essentially we do now minus that, and so that gives us, ooh, this one is rather interesting. So this is a time, but it accepts the duration. Oof, we need a difference actually. Can we have like a difference? We can't have difference. So std time, so we need a difference somehow. Duration from milliseconds. So there should be something like since, I'm pretty sure. System time like since. Duration since, yeah, boy. That's what I'm talking. And it could be, are you freaking serious? Well, I mean, if it's, okay, I see what's going on here. So returns the amount of time elapsed from the earlier point of time. Okay, so you take that, new duration since, all right, so band at, but maybe, so we have to actually follow it slightly differently. So, I mean, name it slightly differently, band at. So this is a newer one, and you use newer one, duration since now, right, duration since now. Yeah, duration since band at, because it's a newer one. And they basically assert the clock may have gone backwards. So if the clock may have gone backwards, what do we do? How do we even handle that? Because that could be something, that could be sort of like an attack. If an attacker gained some sort of like a control over the clock, they could set the clock and crash the entire server. I feel like we shouldn't crash in here. Right, so I feel like we shouldn't crash in here, but yeah, who knows. Expect to do don't crash if the clock went backwards, because right now I just don't really want to bother handling all of that. Right, so and duration. So we got some sort of a duration, so that's cool. Duration. So what we can do with the duration? Can we compare the duration? So it probably implements ordered interface. Does it implement ordered interface? It does implement ordered interface. How can I construct this kind of thing? Can I construct it from seconds? I can, in fact, construct it from seconds. Actually, F32. This is perfect, actually. This is actually perfect. So I can even maybe have something like global. And it's not even a constant thing, so you can't have like a global constant in here, like you would do in Go, right? So because we have band limit in there, right? So we have a band limit. Yeah. So we could introduce the const band limit, then say duration. This is the duration from sex. Is it? Yeah. They also call it sex. Nice one. F32, and band limit is basically 10 multiplied by 60, so it's basically 10 seconds. Right, you can't have that because it's Rust, because fuck you, this is Rust. Right, so can you have something like that in the current stable Rust, or is it nightly feature? I'm not even sure. So because I feel like it has to be like a const thingy, but this one is not const. Right. So we just have pub fn. So there's nothing constant here, so probably we can't have that, even though that would have been super useful. That would have been a super useful. Okay, so what do we have in here? So this is a strike count. This has to be, let's put it I32. What else do we have in here? Cannot find, because this is the outer address. And so integer. Okay, so this could, why did you remove everything? Why did you remove everything? Band. Okay, so you want a reference. What else do you want? Expected system. Okay, so this is not what I thought it is. Excuse me. So I suppose it just, okay, it doesn't know the return type. Yikes. Okay. Freaking. So there is also elapsed time, but whatever. I mean, we're already moving in that direction. So, and for it to know all of these types, I have to explicitly say them. And unless I finish, like, it's very annoying that I have to, okay, so, but I mean, I have no other choice. TCP stream. So if I remember correctly, we're using NAP in there, right? So this is going to be peer address. So this is a socket address, but not really. Socket address v6, right? And we have IP in here, and it's IPv6. Is there something like just a general IP? So if I just, okay, so there's a generic IP address. Okay, that's very cool. Is it hashable? It is hashable. Okay, so that means I can just do IP address, IP ADDR, and the value is system time. So that's cool. And in here, we can maybe even also explicitly say socket ADDR client. So that's pretty cool. So IP ADDR socket ADDR. All right, so let's go through the compilation errors. So expected, so socket ADDR. Okay, so that means we need to take the IP. What else do we want? So finally, so now we inferred all of the necessary types. Oof. So band at is a reference, now is not a reference. So that means I have to get now by a reference. Can I just dereference this thing then? Okay, so I managed to do that. Cool, cool. So last message and strike. Okay, last message is going to be system time. We can just put now in there, and the strike count is going to be 0. All right. Okay, so I think we're done. And cannot call non-constant. And what's funny is that I probably won't be able to even do something like that in here as well. Right, because you can't, F32s are not, you can have them as constants. Look at that. You can have F32s as constants. Duration from sex is const. Really? Let's take a look. Let's take a look at the sex. Duration from sex. Duration from sex. It is const. Would you look at that? Wow! Wow! Whoa. Whoa. All right. Duration. Duration from sex. But I mean, I want, fuck me, mate. Fuck, but I want a fractional part. Disappointed. Anyways. Okay. So duration since, and we've got this kind of thing. That's cool. And if the duration is basically greater or equal, it depends on how we even do that. Band limit greater or equal to band limit, right? We actually delete that band motherfucker from this thing, and I'm pretty sure we won't be able to easily do that because of this kind of shit. I'm pretty sure we won't be able to easily do that. I really doubt that. Though we could try to map it. We could try to do and then or something like that. So we can do it like that. So okay, it's mutable. Band at, and we do then, or maybe and then, right? So and in here we get band at. Right, and inside of this thing, this is what we do. And essentially, if it's greater than that entire thing, if it's greater than that entire thing, we basically return none, right? We basically return none, and that effectively, so that single return none acts like effectively setting it to false and maybe potentially deleting, but we'll get to that a little bit later. Otherwise, if it's not, we just keep in the band at as it is. So we're just keeping it as it is. Right. And what's interesting is that, so we could do a very interesting thing. So people say that there is a remove method in hash map, right? So which effectively just takes it out of there and everything. So that could be useful. Right, so you accept that. So we're taking this thing out of the hash map. We're taking it out of the hash map. And then we continue. So then later on, if we're still banned, we'll put it back into the banned MFS. That is very actually cool. So that works out kind of well. So if let sum band at, right, we can even, maybe we can even do something like this. If band at is sum, we probably want to answer you're banned, motherfucker. You're banned. That's what we want to say. Right, so that's basically what we want to say. You're banned, motherfucker, and we want to close the connection. Otherwise, we want to do something like this. So here we want to do is none. We simply would do it like that. And it's translated almost exactly as it was in Go. Isn't that cool? Right, so if it's not none, right, if it's not none, we want to put it back. So, and to put it back, it would be just easier to do it like let sum band at band MFS insert author ADDR IP. So we're just like literally putting it back, band at, and this one goes here. But we also have to say something to the author, right? So we also have to say something to the author. Author as ref, and we want to write something to them. But it's writable thing, so that means we should be able to do something like write ln, like so, and we can say you are banned, MF. You're banned, motherfucker. You're banned. So, and in here, so maybe we don't want to dereference it too often, right? So I can do something like author like this. So then I can just use it like that, and then author. Can I explicitly close this entire thing? Is that something I can do? Right, if I have a TCP string, can I explicitly close it? I don't think so. I want to be able to explicitly close it, but I don't feel like I can. So people say that I probably need to drop it, like it's hot, but I didn't feel like it's okay. So I can try to do drop. So I know that drop is like a destructors of Rust. So that yeah. So okay, well, we can try that and see how it goes. We can try, but it's probably, it has to be mutable, right? So it has to be mutable. You can't really easily drop that. You can't easily drop that, MFS. Is it going to like that small little thing is gonna fuck us over really, really hard. So okay. So band at we don't have to do that anymore, right? So we don't really have to do that anymore. Band at expected, yeah, it has to be sum, so that's understandable. And in here, expected just, okay, so you want a copy of this thing. Sure, I can give you a copy. All right, and drop, you can't just easily drop that. Method not found at TCP stream. That's understandable. Shut down. Okay, so we can just give it a try. TCP stream shut down. Sounds good. Why did they call it shut down? That's such a, well, I mean, it's actually kind of a common term for this kind of thing. Okay, so let's just call shutdown. Thank you so much. So this is a shutdown, and it may or may not return something. So in this case, we're gonna just do expect. I probably just don't want to even care about it, right? So just like shut it down. So what does it say? An argument shutdown is missing. What do you want? How shut down? Okay, that's very interesting. Ooh. Possible ways that can be the reading portion of TCP. Okay, let's do both. Shut down both. It doesn't know that. It's part of the net. Shut down. So it has to be. This thing doesn't have to be mutable, sure. And author. Ooh, it has to be mutable, by the way. It has to be, because I'm basically reassigning it back. Probably you can simplify this entire thing, but I mean, who cares? Cannot borrow as mutable. So what does it suggest? Just add mutable. Okay. Will that solve it? I thought we'll never get out of that maze, but we managed to do that. Holy shit. What the fuck? We managed to crawl out of that labyrinth of borrow checking bullshit. Holy fuck. For a second I thought we're gonna die, we're gonna get lost in this labyrinth because of this kind of situation. Whew. But yeah, luckily there is a shutdown in here. Oh boy, holy fuck. Okay. You can definitely simplify this, it's just not obvious. Yeah, I'm pretty sure. But I'm basically translating Go code to Rust 1-to-1, and that's because that's why it's kind of weird like that. Right. So yeah, yes. Okay, the disconnect is implemented correctly, right? So well, we forgot one little thing. We forgot to say how much sex you have left. So that's very important. Sex, right, so sex left. So when the question is what is sex? So basically take the band limit, right? So we take the band limit and we are subtracting the band at, right? So we do have band at, so that's totally fine. So here, yeah, this one is very interesting because we basically moved it inside. So we will probably have to reorder some things, but that's fine. So we take the difference between these two things, and both of them are duration. Can I now take the duration and translate it to seconds? Duration, right? 2 secs. So there is a as sex f32. We need a sex f32. All right, so that's cool. We can do it like that. As sex f32. As sex f32. Okay. So expected. So expected because this is duration What? Mismatch type, duration. Oh, it's a system type. Really? Band add is a system type? Wait, what? I'm confused a little bit. Oh, yeah, you take that difference again. You take that difference again. But that difference only makes sense. Okay. Whatever. So we can probably call it diff, and diff. So okay, we're good to go. So that is very apogers. That is very apogers. So disconnect is implemented correctly, so that's totally fine. So now we need to implement this monstrosity of the situation. This monstrosity of the situation. Okay, good. So now, what do? We need to take the author address. So we've got the author address. So then we need to find the author. Right, so let's do author clients get author DDR, author ADDR. And we also need now, let now. So this is kind of important. So this is a let now. So we first need to check that author still exists within the clients, because essentially you can have a situation when the client is already disconnected or banned or something like that, but there are still messages from them in the queue, right? There are still messages from them in the queue, and you basically wanna process all of them. To be fair, maybe new message should actually, yeah. Things like client disconnected and new messages should not directly accept TCP streams and stuff like that. They probably should not. What they should do instead, they should accept IPs, right? So they should accept IPs. Maybe this is something that we have to implement. I think that's a generally good idea, right? So yes. So because we're going to be querying those things from there anyway. Right, we're going to be creating them from there anyway. And by the way, because of that, maybe you have disconnects from things that don't really exist anymore, but it's quite unlikely. It's quite unlikely. So, so we need to have a socket address, right? So this is the author socket ADDR, and this one is a socket ADDR as well. Socket ADDR. So let's go to the compilation errors and just sort of port that a little bit. Just port that a little bit. So what do we have in here? So author ADDR. All right, so this is author ADDR. We don't have to do that anymore, but we can get the author. And now if let, we can even inline this entire thing. If let some author ADDR, maybe we don't even need to do, well, we'll see. We'll see. So this one goes here, and yeah. So that works out, hopefully. So new message author ADDR does not have a field author ADDR. Aha. So let's call it author ADDR then. So that's totally fine. So author ADDR. So that is fine. Author ADDR. Okay, that even should have done that earlier. That's very cool. That's very cool. All right, so author ADDR. So that means we're on the right track. Okay, so this doesn't have to be the that gets rid of the clone, by the way. Right. So peer ADDR. Hopefully that's something we can do. Maybe we have to do as ref. So it could be, so it may fail. Right, it may fail. So we removed that code. Yeah, okay. So we removed that code. So one of the things we probably want to do, we want to do author ADDR, right? Author ADDR, author. I think that's how you pronounce that, right? Author ADDR. I'm not sure if you need this thing, but anyway. So expect to do cache the peer address. Right. So because we're going to be doing that on each sort of read, I think it would make sense to cache this entire thing. Right, and the same goes in here. So we can just do it once. I'm pretty sure we can just do it once. And here, just do author ADDR and then simply bytes. We can factor this stuff out like so. Am I even considered an epic rooster now? Am I an epic rooster now? Look at that. Look how easily I factor shit out. Outside the loop. Yeah, that's actually a good idea. Yo, yeah. And yeah, that's a good idea. So we essentially, if you can't do that, we can even crash the client right away. Yo, okay. So that solves even more problems than I expected. Okay. Println error could not get peer address of, well, whatever. Error, something like that. Yo, motherfucker, yo. That is absolutely boogers. So what's up with that? So author is not even used anymore, so that's expected. What else do we have? Last message is not used. Unused result, so that's fine. Anything else? We have last message and strike count. I guess we're Gucci. I guess we are in fact Tamaguchi. So we have this situation when you may not have some clients in there. So now what can we do? Then we have to calculate how much time has passed since the last message of the user. Right. Nice. Lost message. Yes, lost message. So yeah, I'm just thinking why there is no semicolons in here. This is Go actually. This is actually Go. All right. So now we need to find the difference again. For some reason, finding the difference is a little bit painful, right? Because you have to do this kind of thing, but we can now copy paste things, right? But in here, we don't have to do band at, we have to do author last message, right? So author last message. And if the difference is greater or equal than message rate, only then we would authorize that specific message, right? Only then we're authorizing that. And the message rate is basically a duration, right? Message rate. Duration from secs. It's going to be 1 second. Duration from secs. So didn't flushed. And that's basically it. So we can go to the compilation errors, right, just to see if... Okay, so the only thing that is left in here now is a strike count. This is because we're striking the user around in here, right, so somewhere here. And how do we strike the user? First of all, we increment their strike, right? Oh, and incrementing their strike will require to modify them, right? So we take author strike count, we just incremented by 1. And here we get it as immutable, so that means we have to get it as mutable. That makes sense. But here comes another interesting thing. If author strike count is greater or equal than the strike limit, the time has come to ban this MF. The time has come to ban this MF. But that also, well, yeah, we don't have to modify the map, so everything's fine. I thought that we'll have to remove the connection from the map. We don't have to do that. It could be done later from the client disconnected, so that's totally fine. So what do? We add that to the list of banned MFS. By the way, maybe it would be better to actually put go at the bottom. Banned MFS, we insert author ADDR IP, and we clone this entire thing. And what we put in there, we put now, right? Then we take an author connection, all right, an author connection, and we just write, yeah, we just write you banned MF. You are banned MF. Where do we get the author? So when it's connected, we just do it like that. So what I'm thinking is that, can we write ln and then say you are banned MF, like so, very dramatically, and then we shut down this entire thing, like so. We shut down both of these motherflippers, like so. Let me see. So you're banned MF, and then we shut it down. So that means it will be removed later. Okay, so let's go through compilation errors. Strike limit is not implemented, so this is going to be just like 10, if I remember correctly. That's just 10. Cannot borrow as mutable. So can we do just as ref as yo, look at that, we managed to do that. So, but we don't check whether a sequence of bytes that we're sending is valid UTF-8. We don't check for that, right? So this is something that main Go should do as well, right? So it does that too. So as you can see, it just validates that thing. So what we can do from UTF-8, we go, and that does validation for us. So that's very cool. So this is going to be Rust, and within this thing, we just take the bytes, right? We just take the bytes, and we're just constructing, I'm surprised, str from UTF-8, right? So str from UTF-8. If let some text, we're going to be just sending that text there. I wonder if I can simply write that text like so. Well, I mean, the compiler will tell me if I'm doing something wrong, but whatever. So otherwise, we're just striking that user. So, and banning them. Okay. So what does it say? No function associated from UTF in the... that is surprising to me, because... Isn't it part of str, or is that because I never imported? Okay, so std str. Yeah, that makes sense. Okay, so this is a reference, that's fine. What else do we have in here? Okay, so yeah, this expression has type result. Oh, okay, so this is okay. I'm not gonna probably log that. Okay, so it doesn't like that. So you cannot just write that string. One of the things we can do write ln this thing as a ref and just write that text. Just squish that cat. Simply squish that cat. Boom. I think we fully translated this mother flipper. str has bytes. So it's kind of funny. So we are translating it to str just to validate that it's UTF-8, and then we're going to be taking bytes out of that str to write them. We could do that. But that's kind of funny. You can reuse the bytes. That's a good point. That's a good point. So what if I... Okay, let's actually go back. That's funny. Byte. So, right, because we validated them. Can I do that, or is it gonna be... That's a very interesting way of doing that. Is there something validate is valid UTF-8? So UTF-8. Because it's kind of weird, honestly. Is there not valid UTF-8 some kind of function? Yeah, like, I don't know. That would make sense to me. But if it's not, is that how Rust developers you can do is okay? Sure, that's also fine. Right, so you can do is okay. All right. I just can't believe that is it. We managed to translate this entire thing. So, yes. I don't know if I want to do the DDoS test right now. Right, so I think I'm gonna just test it locally. And then we'll see. 6969, hello. We can't really see shit, but that's fine. So telnet. Hello. All right, that's cool. So I want to actually do something like close. And let's try to DDoS this thing. We're gonna cat def urandom and nc 20001 6969. I didn't get banned though. That's funny though. So why didn't I get banned? Because I would expect it to tell me at least you're banned, motherfucker. Yeah, so we'll probably use a lot of let in here. Maybe we should actually like log some info in here. Right. We can do eprintln could not send banned message to do we have the author ADDR? Yeah, we do have author ADDR. Author ADDR error. So it's actually put as many errors as possible. Right. So when we do shutdown, it may also fail. Map error. So this one has to be map error though. Okay, error could not shut down socket for author ADDR because of the error. That's understandable. So let me try to compile. So what does it say? Yeah, so you still need to do it like that, right? Because we're ignoring these things. What's the other stuff? So map error and eprintln error could not write, could not broadcast message to all the clients from author ADDR because of this specific error. All right. So I want to also specify where exactly all these things are happening. Could not send banned message. Shut down. All right. And this is, well, we can copy paste this entire thing. It's literally the same. All right. So we are ignoring this entire thing. We could probably do map error in here. So could broadcast, could not. Eprintln error. Could the server could not send client. Okay, so we could probably copy paste this thing. Yeah, who said we can't do that? So in this case, we just don't care, right? We just simply don't care because we're already like recovering from the failed situation anyway. So it just doesn't matter at this point anymore. And that's basically it, I feel like. All right. Okay, go. Hello. Honestly, I think I need to also log different situations when somebody connected and stuff like that. You know? When somebody connected and stuff like that. So maybe I could just steal some stuff from here. Yeah. So for example, somebody connected. Where is that thing? Yeah, so here. Eprintln info client author DDR connected. So it actually doesn't have to be like this, but yeah. Then we can say client disconnected. So this is disconnected, and in here, so we just don't do anything here. So we're skipping all of these things. I don't think it makes sense to even log that. We can basically, yeah, let's just log it like this: println info client client author ADDR send message. Ooh, and here text would have been useful actually. Text would have been useful, so that's actually kind of funny. So if let OK text, because we're printing it like that, so text would have been more useful. That's cool. So, and when we're striking somebody, it would make sense to also do that, to also log that. Info client author address got banned. Right. And we're doing it like that. Logging a lot of shit. Like as much as possible. As much as possible. Alright, looks good to me. Looks Gucci, looks even Tamaguchi, I would even say. Alright, so boom. Client has connected, hello. Sent message, hello. Did I put slash n somewhere? No, I didn't. Oh, slash n comes from the slash n in here when I pressed it in here. God damn it. So maybe I should print the bytes then. Yeah, let's print the bytes then in this case. So what does it say? Oh, okay, so we can just do the debugs one, right? So it could be debug one. How do you do debug one? I don't remember. So I think it's the other way around. Yeah, it's the other way around. Okay, so boom, test. All right, so this is the bytes and everything. Okay. So client, blah, 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 connect it, and then we can close the connection. Ooh, got it. I think I know what's going on. I think I know how to fix this shit. So if, okay, end the file if n is equal to 0. Okay, n equals 0. Right, there we go. Greater than 0. So I'm gonna do a very dumb thing. Otherwise, just, you know. So let me see. Read. Read. It's a read one. Pull some bytes, blah blah blah. This function. Oh, the return. So if the return value of this method okay, an implementation must guarantee that a non-zero n value indicates that the buffer has been filled with n bytes. Then it indicates one of two scenarios. The reader has reached the end of file and will likely no longer be able to produce bytes. Note that this does not mean that the reader will always no longer be able to produce bytes for asynchronous situations, right? So that's understandable. The buffer specified was 0 bytes in length. Okay. So that is cool. That is cool. So error reached. So we can say that author client author ADDR reached the end of file. Yeah, and we're sending that shit in there and something like that. Okay, so that's cool. That's cool. I think we figured it out. So actually logging everything was useful, right? So we managed to figure it out. Okay. Close. Fuck. Okay. It's fucking single line. Or maybe break. Okay, so yeah. Because that would break out of all of these things automatically because of the question mark. Right, so... Alright. So, okay, so that means we probably also want to do something like this, right? Because it returns result. That's understandable. Yeah, that's cool. So before we never actually got out of that loop, so that's kind of funny. Yeah. Finally. So maybe logging reached end of file is not particularly useful. Reached end of file, so I'm not going to do that. Okay, so we do that and close, disconnect it. Hello, test. Epical. So now, close and see a boom. You bam, motherfucker. You bam. It's broken some pipes. Could not send banned message. Oh, did I actually send the banned message? Could not send because we shut down. That's really funny. Huh. Oh yeah, because we were maybe receiving some stuff from. Okay, I can see that being a thing, right? So I can see that being a thing, but it's not that big of a deal. So then I can try to connect. Right, okay, so you banned MF in this amount of seconds. Okay. Right, that's cool. So we probably need to log something. Your banned MF. This is how much left. It would be nice to just say something like info client. So we already say client connect. Yeah. So we say client connected in here. Client ADDR tried to connect, but that MF is banned for sex. Now what? I'm gonna extract the sex out of it, like so. There we go. Sex. Okay, so what the fuck is that? Right, so NC, boom. Okay, so we try to connect and but that MF is banned for this amount of seconds. Okay, so that's cool. Try to connect, but that MF is banned for this amount of seconds. So and then we can do that. Hello world test. Easy not epic. Easy not epic. So we can try to DDoS that shit. We could try to DDoS that shit. I think logging stuff as just bytes is fine, right? So because it basically automatically screens any racist Nazi shit. It also automatically reduces possibility of escape sequences or something like that. So that's actually good. So I'm not gonna be showing on the screen anything like super sensitive, but you as a client, when you connect, be aware that some people may send some sensitive stuff like racist or Nazi shit, and I absolutely do not approve of that. This is just like nature of this entire thing. And I haven't implemented any authentication to weed out some other people, so connect to that server on your own risk. So we're on the same page on that, right? So everything's fine to connect to that on your own risk. So if you're scared of scary hackers, so do not connect there. But to be fair, I don't think they'll be able to do something super scary, right? Because like again, like there's no possibility of escape sequences or anything. We literally validate UTF-8 and stuff like that. Leak IP. IP is the same, by the way, as usual. So actually, I just reinstalled the same machine. Are you printing? Oh, fuck. We also, yeah. We need to screen the sensitive data. Thank you for reminding me. Oh, this will require to do a lot. All right. This will require to do a lot of work. But what if I deploy on... I feel like escape sequences are valid UTF-8. Ah, fuck. All right, so let's not do DDoS now. Let's not do DDoS. No DDoS for today. So yeah. All right, so we rewrote this shit in Rust. Surprisingly, it worked fine, right? So we have this thing working fine. Yeah, so that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreational programming session with Azuzin. Love you all. Mwah.